So there's two ways that we can talk about the measure of center. We can usually either talk about the mean or the average or the median. And so the question is always like, well, which one do I use and when do I use it? So it kind of depends. It depends on the shape of the distribution and whether there are any outliers. It depends on the shape of the distribution and whether there are any outliers. So we're going to have to look at that and consider that when we decide, should I use mean or median? Okay, so here's kind of a picture. When we have a distribution that is skewed, so do you guys remember which way is this one skewed? Left. Skewed left. Okay, it says it. And remember, it looks like that weird left foot that I draw on the paper. And then this one's skewed to the right. And so what happens when we have a skewed distribution is our mean has to average in these lower values if it's a left. My mean has to average these in, and so it kind of gets pulled down toward that skewed data. And same thing, if it's a right skewed distribution, my mean gets pulled up by that skewed data. And so with skewed data, the mean is going to move way more than the median does. The median will kind of stay pretty close to where it started. And so with the mean, if I have a skewed to the left distribution, my mean is going to be lower on the number line. My mean is going to be lower than the median, always. So if you know the mean and the median of a distribution, you can tell if it's skewed or not. If they're approximately the same, roughly symmetric, then your mean and your median are going to be pretty close to the same number. Okay, so your mean, they're not always going to be exactly the same, but they're going to be pretty close. Okay, but if you have a mean that is lower than your median, you have a left skewed distribution because the mean got pulled to the left. If your mean is bigger than the median, you have a right skewed distribution because your mean got pulled to the right. Does that make sense? Perfect. All right, so that is how you can kind of tell from just the mean and the median what your distribution is shaped like. All right, so if a distribution of quantitative data is roughly symmetric, if a distribution of quantitative data is roughly symmetric and has no outliers, you're going to want to use the mean to measure the center. Roughly symmetric, no outliers, you're going to want to use the mean to measure the center. But if the distribution is strongly skewed or has outliers, you're going to want to use the median to measure the center. So symmetric, we get mean, skewed, median. Okay. All right, so here's our example from the very, very, very beginning. This example was about New York workers and their travel time to work. And we have 20 randomly chosen, and that's the dot plot. And we have the mean and the median marked for you. So the median is 22.5. The mean is 31.25. All right, why is the mean larger than the median? Why is the mean larger than the median? What do you guys think? Think about the shape. What do you notice?
It's strongly skewed and it has outliers.
Very good. We have a strong right skew and we have some outliers. And so the mean is having to average out these really big numbers, right? The median doesn't really get, it doesn't really get messed up as much as the mean does. So the mean has to average the outlying values. I believe, so we talked about that on Friday, we call that a specific thing. What's it called when the median doesn't really want to move? What do we say the median is? Resistant. Very good, Isabelle. The median is resistant and the mean is not resistant. The mean is going to move because it can't resist averaging in those outlying values. So the reason that the mean is so much larger is because the mean is not resistant. And this distribution is right skewed. I ran out of room. This distribution is right skewed. So the mean is not resistant. This distribution is right skewed. So the mean gets pulled to the right. Okay, so which measure of center would be better to describe a typical travel time to work? Median. Yep. So if I wanted to describe a typical travel time to work, I would probably want to use the median because of the fact that it is resistant. And there you go. So the median gives a better summary of the middle of the full amount of data. If I use the 31, that there's only 7 things that are bigger than 31, but there's a lot more that are less than 31. So like 31 is kind of not really an average. It's not a good representation of what most people are doing. Most people are somewhere in the 20, 22-ish range. Cool? Cool. All right, you guys. We're gonna do our little see what you remember, and then I'm gonna show you something cool on your calculator. Actually, you know what? We'll do this together so that I can show it to you while we're doing it. So that's what we'll do. All right, so have you ever noticed that bags of chips seem to contain lots of air and not enough chips? You guys ever noticed that? There's like, why? A group of chip enthusiasts from Kitchen Cabinet Kings collected data on the percent of air in each of 14 popular brands of chips. Here are the data along with the dot plot. So they went ahead and put the data on the dot plot for us. And it says that we need to find and interpret the median. So how can we find the median of this data using our dot plot? Yeah, let's do it. So we're basically just going to cross off the higher, lower, higher, lower, higher, lower. Go find the middle, right? We're just crossing off numbers until we find the middle. So let's see. All right, so 1, 2, 3, 4, 5, 6. Okay. So did y'all get down to there's 2 things in the middle? Okay. So what are those 2 values? Looks like 45 and 46. You guys think that? Okay. So what do you think the median is then? 45. Perfect. So remember when you have 2 in the middle, you average them. So we would have 45.5, and this is percent, okay? And then the interpretation of that would be half of the data has more than 45.5%, and half of the data has less than 45.5% error. So half of the data has more, and half of the data has less. Middle cuts it directly in half. All right, so for this next question, I want to show you guys some really cool features that your calculator has. I know that you guys know how to find the mean, and I know that you can just add up all these numbers and divide by the number of numbers, but I want to show you a different way to utilize your calculator to do this, okay? So if everybody can go to your calculator and go to Stat, Edit. So Stat is very close to the arrow buttons. Go to Stat, Edit. I'll write this on the board too. So what we're doing, we're trying something a little different here. We're going to do Stat, and then we're going to go to Edit, So you basically just hit enter on edit, and you're going to put your data into the list. So input the numbers into L1. So probably, I'm hopeful that you guys have done this before, that you've put numbers into a list before. Yes? Okay. Put your data into the list. It does not have to be in order.
All those?
Yes. So put all these numbers into the one list all the way down. So you're just putting all of those into the list all the way down. Do you have... So after you put your data into the list, okay, whoops, did not mean to do that. After you put your data into the list, what you're going to do is you're going to again, so right there from that list, you're going to hit the stat button again. So stat, hit the right arrow so that the calc, because we're going to calculate, is highlighted, and hit enter. And then you're going to choose option 1. It says one variable stat. Stat calc 1, and it says one variable stat. And then it's asking you, hey, where's your list? And it should already say L1, because that's hopefully where you just put your list. Then it's asking you what's the frequency of your list. And so that you can just leave blank. Okay, you're not going to need that for a long time, but just leave that blank for now, and then hit enter on calculate. When you do that, you should see a whole bunch of stuff come up on your calculator screen. Okay, the first thing that you should see is X bar. Does everybody see an X bar?
Yeah.
You can see it, Royce? Yeah. Okay, cool.
What?
So let's see where you're at.
Okay, so like I do this,
Yep.
and nothing from, like, there's no...
Oh, okay, so you have just a little bit of an older calculator, which is fine. I can update it, I'll do that in the next few days, but hit enter, and it does it automatically. You don't see those things. Yep. So the first thing you see is X bar, which is our average. Yes. Yes. All right, so you guys should see at the very top, you should see X bar, and it should be this number, 42.57%. You guys see that? Cool. That is the fast way to find the average. And not only the average, it tells you all the other things too. So if you look, you see X bar, and then you see the sum of X. That is, you should see 596. That is the sum of X. So that's if I add all these numbers up, that's what I get. Then the next thing you see is SX. We're going to talk about that probably tomorrow. That's standard deviation. So we'll talk about what that means and what that is. And then if you see there's a down arrow, that means there's more data down below. If you hit the down arrow, you're going to actually see the minimum value. You're going to see the median. The median is what we just found, 45.5. That confirms that our median was correct. You're going to see the maximum, and then you're going to see this thing, Q1 and Q2. We're also going to use that in the next couple of days. Okay, so this is a really cool way that your calculator can give you all of the data that you really need about a data set in just one little step, instead of having to do all those other steps all at one time, or all at separate times. So any questions? Did everybody find this on your calculator? Those of you who don't have a calculator, do you know where it is? Can you bring it tomorrow? Okay, yes. Okay.
I just need to go down to the library and check it out.
Okay, do you need the form?
I have one.
You have one? Okay, perfect. All right, very cool. So that is how you can do mean. So you don't have to do this thing if you have a bunch of data. You can just do what we just did. So everybody have the steps? Good? Perfect. Last question. What measure of center do you think would be better to describe the typical percent of air in these bags of chips? What do you guys think? Should we use the mean or the median? So look at the distribution. Do you think the distribution is skewed? It's a little bit skewed to the left. So again, that's why your mean, 42.5, is lower to the left of the median of 45.5. So the mean got pulled down by the skew, and the median stayed where it was because it's resistant. So since the median's resistant, that would probably be better in this skewed distribution. So we would probably want to go with the median. Let's see. Yep, the median would summarize the center better because we have a left skewed distribution. Cool. What questions do y'all have?